language is pretty fuzzy to begin with, and so it's part of the way that that you can kind of hide some of this does trace back to the way in which like the input to these models is really embeddings. It's not really words. The words get transformed to embeddings. And part of the way that you can hide information in a model is essentially by tweaking these embeddings and shifting definitions of things. And it's been some models, like by dissecting or disassembling the models, some previous models, it's been discovered that there are some like really strange embeddings that are artificially like a specific example is an embedding that was actually two words put together that were politically important, and typically it was just very unusual for this token to be in kind of like the vocabulary of the model in the first place, and it was kind of like an indication that there had been some kind of manual tampering with the embeddings themselves, and through it's kind of hidden. Like until somebody found that, it was kind of hidden. It's not disclosed how biased the embeddings are. It's not disclosed whether or not there's been any kind of like political editing of the tokens or specific, like the strategic insertion of tokens into the embeddings. But there has been, and that's one way that you can just straight up hide information in the model, messing with the embeddings. But also, man, it's really hard to like reverse the training examples. It's hard to figure out where in the model these like refusals are located. It's hard to figure out where in the model certain like ideological constructs like could be embedded. Like let's say that the training examples were chosen to to favor a specific ideology and denigrate a specific other ideology. Well, okay, what's the signature of that? Like, what's the evidence of that after it's been done? Like, I mean, for our purposes, let's say that we know that this has been done. Like, that that's going to be biasing the responses, and you can see it biasing the responses if you choose like specific, like specially crafted inputs. But like, how would you find a signature of that tampering? Like, how would you know that there are specific ideologies like encoded in the weights of your model? And it's not easy to know is part of the answer. It's not necessarily impossible, but in this way, or actually, yeah, this is just another way that you can hide information inside language models. And so for all these reasons, like the cultural stamp of the laboratory that made the model is pretty strong. There's a whole different thing about fine tuning and people making interesting reinforcement learning layers that are applied even after these labs apply them. And so what that means is like you can kind of imbue a language model with a new culture at a certain level. And but fine tuning, I think, is a whole different can of worms.
Okay,
Yeah.
well, in that case, maybe the next video will be about fine tuning.
Yeah, I mean, I think that might be a good place to pick up, because that partly explains why there are so many different models on Hugging Space.
Yeah. Also, I mean, there's just also the idea when talking about neural networks, how it's very different. Like artificial intelligence is different than the human brain, and like some of the similarities. But let's save that for another topic.
Yeah, I know. Well, I mean, so I think maybe then a way to close it all off is like the transformer architecture that we started with. That is the basic algorithm that we're talking about here, and it happens to be an algorithm that works very nicely on GPUs, and it happens to not be anything like the way that humans think.